Hello, welcome to Afatronics-tv. My name is Bismarck Donko, but you can call me Engineer. Today I want us to learn about resistors. So, as you can see on the screen, we have different types of resistors. But what exactly is a resistor? So a resistor can be defined as an electronic component that limits or controls the flow of electric current in a circuit. So in simple terms, you can think of, let's say, a water flowing through a pipe. Now you see we have a section of a pipe where it reduces the flow of water. So if we should think about a resistor in that manner, we can say that a resistor is like a narrow section of the pipe that slows the flow of water. So in a circuit too, we want to flow the amount of current that will flowing through the circuit. So we have a resistor that helps us to do that. So at one point in time we have a certain amount of current that can flow. Maybe we want 0.5 to flow. At one point in time we want 0.1 to flow. So if you look here, we have limit current to protect other components. It also drops voltage to required levels, controls signals levels in electronic circuits. It also generates heat by converting electrical energy. Now the unit of a resistor is ohms, and a resistor also follows Ohm's law. So if you have your voltage is equal to I times R, so to find a resistor is just a matter of change of what subject. So here V is your voltage, I is your current, and then R is your resistance. Now we have different types of resistors. We have a fixed resistor, a variable resistor, then we also have some special resistors as well. So let's take a look at it. So here you are with some pictures here. So when you look at it, we have linear resistors, and then we have some non-linear resistors here as well. So let's first of all look at linear resistors. So under linear resistors we have fixed resistor and also a variable resistor. Now under fixed resistors we have carbon composition resistor, wire one, thick film, thin film, fusible, cement, metal oxide, carbon film, and metal film resistors. And also for variable resistors you have potentiometer, rheostat, and trimmer. Now if you look at nonlinear resistors, here we have a thermistor, LDR, varistor resistor, and also flexible resistors. Now what's the difference between a fixed resistor and a variable resistor? So as the name goes, fixed, it means that if a resistor has a value of, let's say, 5 kilo ohm, it cannot be changed. It remains 5 kilo ohm. Whilst a variable resistor, let's say this variable resistor here, on top here you see an inscription, let's say 50 kilo ohm, but with the help of this knob you can vary it. You can reduce it to, let's say, 20 kilo ohm. You can even reduce it to 0. So that makes this one a variable resistor. Now looking at the fixed resistor, how do you know the actual value of the resistor? Now mostly when you look at a variable resistor, you see that the actual value is always inscribed at the top here, while with the fixed resistor all you see is some colors. So with the help of these color codes, how do we find the value of this fixed resistor? Though we have some fixed resistors here. Usually you also see the value of the resistor being inscribed on it. So for example, Y1 thick film, cement film, metal oxide, you see that the value is inscribed here. So for example, you see here 5W75RJ. So it means that with this cement film, the value of this resistor is what, 75 ohm, and the wattage is what, 5 watts. But when it comes to carbon film fusible, you can see that you can only know the value either using a multimeter or with the help of the color code. So here let's learn how to use the color code to find the actual value. So before we do that, let's look at a linear resistor and then a nonlinear resistor. So here we see that a linear resistor is a type of resistor whose resistance remain constant with increase in the potential difference or voltage applied to it, just like I said. And also a nonlinear, we said a nonlinear resistor are those types of resistors in which the current pass through it's not exactly directly proportional to the potential difference applied to it. So as you can also see here, so that's the difference. So let's look at the color code. Yeah, so here you are with some color code chart. Now when you look here, you can see some colors. So you can see black, brown, red up to white here. Then we have significant figures, we have multiplier, we have tolerance, then we also have temperature coefficient. We also have the fill rate here. So when you take a resistor, usually you see some color bands around it. So here you can see a 3-band resistor, 4-band resistor, 5-band resistor, 6-band resistor. So let's start with maybe a 4-band resistor. So let's look at this one. So when you look at it, the first color here that you see is what, gray color, gray. So when you are given the resistor, how do you determine whether this is the first color or this one is the first color? So usually depending on the brand, there are some resistors you see that between the last color and others they will leave a certain gap here, as you can see from this one. So once you see a gap like this, you know that, oh okay, the first color starts from this side. And also you can also use the color to determine, because there are some colors usually it will not be a first color. So for example, this one, once you see gold, you know that okay, gold is the last color, so you start from the opposite side. So let's look at this resistor. So we have gray color, we have red, then we have orange, then the last one is gold. So if you have gray as your first color, then come and look at the significant figures here. So you come here, then you see that once you have gray, then the number is what, or the figure is what, 8. Then because it's a 4-band resistor, your third color is your multiplier. So these are your significant figures, then your third is your multiplier. So for your multiplier, don't come here, you come to this section to look for your multiplier. So let's look at the second one, which is red. So you come here, red is what, 2. So now we have what, 8, 2. Then orange is your multiplier, so come here, so orange is our multiplier. So if our orange is um, our third, then the multiplier is what, 1k. So we have 82, which is what, 82. So 82 times 1k is what, 82k. So this resistor is what, 82 what, kilo ohm. And because the tolerance, the color is gold, it's what, plus or minus 5%. So you find 5% of what, this 82, and that will be your tolerance. So let's look at another example so that you understand. Great. So this is an example for you. We have another 4 band resistor here. So we have red being the first color, yellow being the second, then you have orange being our multiplier, then our last color, which is your tolerance, being gold. So here let's solve it together. So because it's red, you come here and then look for the number, it's what, 2. So we have 2 here. Then the second color being what, yellow. So yellow, you come and look, we have 4. So we have 2 4, which is 24. Now let's go to our third color. We have what, orange. So multiplied by what, so come and look, which is what, 10 to the power 3. So we have that one here. Then of course gold being tolerance, we have plus or minus 5%. So we have 24 times what, 1k. So we have 24 kilo. Then 5% of what, 24 is what, 1.2. So we have so the final value of this resistor is what, 24 kilo ohm plus or minus 1.2 kilo ohm. So that's the value of the resistor. So here if you measure it with the multimeter, of course because of the tolerance you can get maybe 23.9 or maybe 24.5. So it's still within the tolerance. So once you know the colors, you know that okay, so the exact value is what, 24 kilo ohm. So let me give you some resistors, and then with the help of this color code, try and then find the value of the resistor. Okay, so I can find you some resistors here. Okay, so look at this resistor, find it using the color code, then also try and then find the value of this, and then this one, and then this one. Okay, so here you can see we have green, blue, red, and then gold. So I hope with the color code you should be able to find the value of these resistors. So once you're able to get them correct, that means you really